Hello, everybody. My name is Masaki Takauchi, and I am a PhD student at the University of Osaka in Japan. I'm here today to talk about shadowless projection mapping for tabletop workspaces with synthetic aperture projector. We introduce a synthetic aperture projection mapping system that uses a significantly larger number of projectors arranged densely in the environment to achieve delay-free, shadowless projection for tabletop workspaces without requiring computational compensation. In many of projection mapping applications, users typically interact with content superimposed onto an augmented object. However, this configuration faces a technical challenge that projected light is often occluded by the user's body, resulting in shadows and incomplete projection outcomes. To address this issue, previous studies have proposed systems that spatially distribute multiple projectors throughout the environment. When the projection from one projector is blocked and a shadow appears on the object, another, unoccluded projector compensates by projecting onto the same area. However, this approach suffers from noticeable compensation failures when occluders move, due to system latency introduced by the compensation computation. These failures degrade the overall R experience. To overcome this limitation, we propose a shadowless projection mapping system for tabletop workspaces. Instead of relying on a physically large aperture projector, we build a synthetic aperture using many projectors. On the left, with a single projector setup, shadows are cast when a user's hand or other object approaches the projection surface and blocks the light path. On the right, with synthetic aperture projection setup, like 25 projectors in this example, even if some projectors are occluded, light from the remaining projectors still reaches the surface, effectively reducing shadow formation. To implement synthetic aperture projection and evaluated its shadow removal performance, we installed 25 projectors arranged in a 5x5 grid on the ceiling, projecting the same imagery from multiple directions onto each point of the target surface. This configuration ensures that even if some projectors are occluded by an observer, the majority remain unblocked, thereby enabling a shadowless projection mapping experience. We evaluated the shadow removal performance for both planar and non-planar surfaces. In the experiment using a planar surface, images were projected onto a tabletop. As shown in the video, where the hand is waved above the surface, there is no noticeable latency in the shadow removal process. While a noticeable shadow region appeared in the single projector case, the 25 projector setup exhibited only slight luminance reduction, with no clearly defined shadows. The figure also presents results from touching various locations across the table, demonstrating that effective shadow removal was achieved across a tabletop-sized workspace. An interesting phenomenon beyond shadow removal was also observed. When using a single projector, strong specular reflections distorted the appearance of the projected content. In contrast, with a 25 projector setup, specular reflections were significantly suppressed. In our 25 projector system, the intensity per projector was relatively low, which reduced specular reflections and provided a consistent visual appearance regardless of viewing angle. Since projection targets are not always ideal diffuse surfaces, this characteristic of our synthetic aperture approach represents an important advantage. This is the shadow removal performance for non-planar surfaces. As a non-planar target, we used a plaster bust. Video shows the projection results when a user's hand is placed near the surface. While the single projector setup caused the content to be occluded and disappear, the 25 projector setup maintained the projected content. During informal user studies conducted using the system, we observed that when a large number of projectors were densely arranged, significantly reducing light drop, participants no longer perceived the changes in appearance as being caused by overlaid imagery. Instead, the changes were interpreted as natural variations in the surface's reflectance properties, indicating a suppression of the sense of projection. Suppressing the sense of projection and evoking the perception of altered material reflectance is essential in various application domains such as industrial design, restoration of deteriorated cultural heritage, and cosmetics. Based on this insight, we adopt the sense of projection as a metric for evaluating shadow removal performance. To demonstrate that sense of projection is suppressed and that the appearance is perceived as a change in material reflectance properties, we conducted an experiment. Specifically, we placed 10 sheets of paper on a table without overlapping. Among them, 7 sheets had printed text, and the remaining 3 sheets were blank and displayed projected text patterns instead. Participants were instructed to identify the 3 sheets with projected text patterns. No strict time limit was imposed. They were asked to respond as quickly as possible while maintaining accuracy. They were allowed to move freely around the table and block the projected light with their bodies, as long as they did not touch the sheets. There were 2 experimental conditions, one using the 25 projector setup and one using a single projector. We predict that, if sense of projection is strongly suppressed in a condition, the projected characters become perceptually indistinguishable from the printed ones. This increases the difficulty of the identification task and resulting in longer task completion times and lower accuracy. "17 participants took part in the experiment. Each participant performed the task 10 times under both conditions. Figure shows the average task completion time and accuracy for each condition. We quantified accuracy as the proportion of the 3 projections detected correctly in each trial. The results showed that the time was significantly higher in the 25 projector condition than in the single projector condition. For accuracy, the results showed that accuracy was significantly higher in the single projector condition than in the 25 projector condition. The 25 projector condition resulted in task times about 20 times longer and accuracy 30% lower than the single projector condition. These results demonstrate that the proposed shadowless projection mapping system is capable of suppressing sense of projection, allowing the projected content to be perceived as variations in the surface's reflectance properties. We presented a novel projection mapping system that achieves delay-free and shadowless rendering for tabletop workspaces using a synthetic aperture projection approach. By densely arranging 25 projectors in a 2D array, we successfully demonstrated high-performance shadow removal even in dynamic interaction scenarios. Furthermore, we introduced the sense of projection as a perceptual metric to evaluate shadow removal effectiveness, and through user studies, validated that multi-projector configurations can significantly reduce sense of projection. As a future direction, we plan to explore technical improvements, including distributed rendering systems and faster geometric calibration methods, to enhance scalability and usability.